So where a graph has been given over here and it has a line y equals to 3 and another graph, and over here the points R, Q and P are given. Now what is he asking? Find the first part of the question is what is the x coordinate of P. The second part is y coordinate of Q, and the third part is coordinates of R. Coordinates of R. These are the three questions for this one. So now x coordinate of P. So P, where does it P lies? We can see that this is P over here. This point is P. So x coordinate of P lies on x-axis. X-axis means nothing but what? Y equals to 0. Y equals to 0. And the equation of the graph is given over here. What is the equation of the graph? Y equals to 2 minus log of x plus 1 to the base 3. This is the equation of the curve given. So plug in y equals to 0 over there. So what do I get from there? If I plug in y equals to 0, 0 equals to 2 minus log of x plus 1 to the base 3. So I move these questions later down. So what do I get from there? 0 equals to, or move the 2 to the other side, so it becomes 2 equals to log of x plus 1 to the base 3. Then 2 power 3 or 3 power 2, converting logarithmic form into exponential form, 3 power 2 equals to x plus 1, so which gives me x equals to 9 minus 1, so which gives me x equals to 8. That's going to be the answer. Now y coordinate of Q. Where is Q? Q is on y-axis. Q is on y-axis. Y-axis means x equals to 0. So y equals to 2 minus log of 0 plus 1 to the base 3. Log 1 is 0. So answer is going to be 2. And the next part, the coordinates of R. So for finding the coordinates of R, it is the point of intersection of the line y equals to 3 and y equals to 2 minus log of x plus 1 to the base 3. So both are equal. So 3 equals to 2 minus log of x plus 1 to the base 3. So log of x plus 1 to the base 3 equals to negative 1. So x plus 1 equals to 3 power negative 1. So from there, x equals to 1 upon 3 minus 1, which is minus 2 upon 3. That's going to be the question, the answer for the first part. Now, coming to the second question. Let me quickly write the second question. What does the second question says? AT is the amount in grams. Amount in grams of a certain radioactive substance. We are taking a certain radioactive substance and AT is going to be the amount in grams of that radioactive substance, and it is given by the formula AT equals to A naught e to the power of minus 0.0045 T. Now what is this A naught? A naught is the initial amount. A naught is initial amount, or A0 is the initial amount. Now part A. What is in part A is asking if 5 grams is left over. 5 grams are left over after 800 years. If 5 grams is left over after 800 years, the question is how many grams were present initially? How many grams were present initially? Then part B, what is that? What is the half-life? So what is the half-life of substance? So there are two questions. So how should I be able to solve that question? So we are starting with 5 grams after 800 years. So what am I going to do that? I'm going to take that part A. So equation, what is that equation? AT equals to A naught e power minus 0.0045 t. So it is 5 grams. So 5 equals to A naught, we don't know, times e power minus 0.0045 t. T is how much? 800 years. So from here, what do I get it out? A naught equals to 5 divided by e power minus 0.0045 times 800. You can use the calculator and get approximately the answer 183 grams. So initially I'm starting with 183 grams. Next in part B is being asked, what is the half-life? Half-life means A naught will become A naught upon 2 equals to A naught e power minus 0.0045 t. How many years? We don't know. So we have to calculate the value of t. So what do? A naught and A naught gets cancelled. So 1 upon 2. 1 upon 2 means 0.5. 0.5 equals to e power minus 0.0045 t. Apply ln on both sides. So ln 0.5 equals to ln of e power minus 0.0045 t. So that power comes front. So what do I get it out from there? Ln 0.5 equals to minus 0.0045 t ln e. Ln e value is 1, so no need to write. So from there, t equals to ln 5, 0.5 divided by 0 minus 0.0045. Simplify that, you should be able to get that answer approximately 154 years. So don't forget to write the units. That's going to be the answer for question number 2. Coming to question number 3, solve for x. Log 5x square minus x minus 2 to the base 3 or base 2 equals to 2 plus log 2 log x to the base 2. So everything is base 2. So what are we going to do it out? We are going to convert into log base 2. So what does that becomes? Log 5x square minus x minus 2 to the base 2 equals to 2. 2 can be written as 2 times 1 plus this number goes to the power. So what does it becomes? Log x square to the base 2. So again, this 1 can be written as log 2 to the base 2. So I move this one to the other side, and this one I'll be writing it as log 2 to the base 2. Then again this 2 goes to the power. So what do I get from there? Log 5x square minus x minus 2 to the base 2 equals to log 2 square to the base 2 plus log x square to the base 2. So it becomes log 5x square minus x minus 2 to the base 2 equals to log, addition becomes multiplication, 4x square to the base 2. Log base 2 gets cancels. So what does it becomes? 5x square minus x minus 2 equals to 4x square. Then bring all the terms on one side. You get a quadratic. X square minus x minus 2 equals to 0. X minus 2 times x plus 1 equals to 0. This gives me two answers. X equals to 2, x equals to negative 1. But x equals to negative 1 is rejected because it cannot be negative. So therefore, x equals to 2 is only going to be the answer. That is question number 3. Coming to question number 4. If log 4 root 2 to the base 2 equals to x, log y to the base z equals to 4, and y equals to 4x square minus 2x minus 6 plus z, the question is find y. So log 4 root 2 to the base 2. So what should I be doing it out? Log 4 can be written as 2 square, root 2 can be written as 2 power 1 upon 2 to the base 2 equals to x. So it becomes log 2 power 5 upon 2 to the base 2 equals to x. 5 upon 2 comes front. So log 2 to the base 2 equals to x. So what is x? X equals to 5 upon 2. Now from the next part, log y to the base z equals to 4. So y equals to z to the power of 4. Now the next part, what else has been given? Y equals to, y is z power 4 equals to 4x square. X is 5 upon 2 whole square minus 2x, 2 times 5 upon 2 minus 6 plus z. So z power 4 equals to, when I simplify this one, 25 minus 5 minus 6 plus z. So z power 4 equals to 14 plus z. So just plug in it out and check z equals to 2 will satisfy. So therefore z equals to 2 satisfies. So but y equals to z power 4. So y equals to 2 power 4, which is going to be 16. That is the answer. Now coming to question number 5. Solve for 2 e power 3t minus 7 e power 2t plus 7 e power t equals to 2. So what am I going to do that? Let e power t equals to y. So it becomes 2y cube minus 7y square plus 7y minus 2 equals to 0. So this is a cubic function. So we have to do by long division to find the roots. So what am I doing it out? I am taking 2y cube minus 7y square plus 7y minus 2 and dividing by y minus 1. I'll try with divide with y minus 1. If it's not dividing, then if it is not divisible, then I'll try with y plus 1. So y should be multiplied with 2y square to get 2y cube minus 2y square. Then it becomes minus plus negative 5y square plus 7y. Then y should be multiplied with minus 5y. So minus 5y square plus 5y. So it becomes plus minus 2y minus 2. Then again y should be multiplied with 2 to get 2y minus 2. See that always you try to get it out the first term. So minus plus, it becomes 0. So what this can be written as now? It can be written as y minus 1 times 2y square minus 5y plus 2 equals to 0. Now this can be further be factorized. Y minus 1 times 2y minus 1 times y minus 2 equals to 0. So what do I get from there? I get y equals to 1, y equals to 1 upon 2 and y equals to 2. But what is y? Y is e per t. E per t equals to 1, e per t equals to 0.5 and e per t equals to 2. Apply ln on both sides. So I got 3 answers. What are those 3 answers I got it out? The 3 answers I got as e per t equals to 1. E per t equals to 1 upon 2 or 2 per minus 1. E per t equals to 2. So for all, I am applying ln on both sides. Ln, so that I can get the value of t. So what does it becomes? T equals to ln 1. Ln 1 is 0. Ln e is 1. T equals to minus ln 2. And t equals to plus ln 2. This is going to be the all 3 answers for t. Now come to question number 6. Find the solutions for 8e square minus 2e ln x equals to ln x whole square. And the question is solve this one. So we are going to convert this in the form of an quadratic equation. What is that quadratic equation? 8e square minus 2 ln x times e minus ln x whole square equals to 0. So what is a value? A value is 8, b value is minus 2 ln x and c value is negative ln x whole square. So I am going to use a quadratic formula, or you can factorize it out. I use the quadratic formula minus b plus minus square root of b square minus 4ac upon 2a for finding the value of e. So What do I get it out? E equals to negative of negative 2 ln x plus or minus square root of 2 ln x whole square. So it becomes 4 ln x whole square minus 4 times a is 8, c is minus ln x whole square divided by 2a. 2 times a is 8. So it becomes 2 ln x plus or minus square root of 4 ln x whole square plus 32 ln x whole square divided by 16. So it becomes 36 ln x whole square. 36 ln x whole square is 6 ln x. So plus or minus 6 ln x upon 16. So I take one time plus, one time minus. So when I take plus, it becomes 2 ln x plus 6 ln x upon 16. One time I take minus 2 ln x minus 6 ln x upon 16. So what do I get it out? It becomes ln x upon 2, ln x upon 2, or it becomes minus 6 ln x upon minus 4 ln x upon 16 means minus ln x upon 4. So this is going to be the values of E. So E equals to either ln x upon 2 or E equals to minus ln x upon 4. So from there, ln x equals to 2e, ln x equals to minus 4e. So x equals to e to the power of 2e, x equals to e to the power of negative 4e. That's going to be the answer. Coming to question number 7, find the exact value of x. Find exact value of x. For what? Log x to the base 3 minus 4 log 3 to the base x plus 3 equals to 0. This is first question, part A. Then part B is also there. So what I can do it is log 3 to the base x can be written as 1 upon log x to the base 3. Whenever you write like this, it becomes the main number and the base number get swapped if at all you are bringing from numerator to denominator. So it becomes log x to the base 3 minus 4 upon log x to the base 3 plus 3 equals to 0. So let log x to the base 3 equals to y. So it becomes y minus 4 upon y plus 3 equals to 0. So you will be able to get a quadratic over there. So it becomes y square minus 4 plus 3y upon y equals to 0. So what does that becomes from there? Y square plus 3y minus 4 equals to 0. So factorize it out. Y plus 4 times y minus 1 equals to 0. So y equals to negative 4 or y equals to 1. But what is y? Y is nothing but what? Log x to the base 3 equals to negative 4 or log x to the base 3 equals to 1. So from there, x equals to 3 power negative 4, x equals to 3 power 1. That's going to be the answer. Coming to part B of the question. What is part B? Log x minus 5 to the base 2 plus log x plus 2 to the base 2 equals to 3. Find x. So both are logarithms base, so you can multiply it out. So addition becomes multiplication. So it becomes log x minus 5 times x plus 2 to the base 2 equals to 3. Now convert logarithmic form into exponential form. X square minus 3x minus 10 equals to 2 power 3. This is 2 power 3. So it becomes x square minus 3x minus 10 minus 8 equals to 0. So what do I get from there? X square minus 3x minus 18 equals to 0. So factorize x minus 6 times x plus 3 equals to 0. So x equals to 6 or x equals to negative 3. Again, x equals to negative 3 make this term as negative. So therefore it is rejected. So the only answer is x equals to 6. Next, coming to question number 8. expressed as single logarithm. Single logarithm for question number 8. So 2 log A plus 3 log B minus log C. So how do I this one? It becomes log A square plus log B cube minus log C. So it becomes log A square B cube upon C. Next, second part B in that one. Log 3 ln x minus 1 upon 2 ln y plus 1. So how do I express that one? Ln x cube minus ln square root of y plus 1. 1 can be written as ln e. So addition becomes multiplication and minus becomes division. This is going to be the answer. So that's question number 8. Now question number 9 is again almost all same based upon the what is this radioactive substance, where he has given that At equals to A naught e power minus 0.00012 T. This is the what is this formula for a radioactive substance, where A naught is the initial one. A naught is initial amount. Then what is the conditions given? It was found that At is 79% of the activity. 79% of the activity of the carbon in a living tree. Of the carbon in a living tree. How old is the piece of the wood? He is asking how old is the piece of wood in years, in nearest 100 years. He is asking in nearest 100 years, how old is that wood? If at all it would, if at all it is 79% of that one. So it is 79%. 79% of A naught equals to A naught times e power minus 0.00124 t. So what does happens? A naught and A naught gets cancels. 0.79 equals to e power minus 0.00124 t. So applying ln on both sides. Ln. So ln 0.79 equals to minus 0.000124 t. So from there, I get the value of t as ln 0.79 divided by minus 0.000124. Simplify that, you should be able to get 1900 years. That's question number 9. Coming to question number 10. He has given y equals to log of 2x minus 3 to the base 3 minus 4 intersects x-axis at c, 0. Find c. So it is intersecting x-axis. X-axis means nothing but what? Y equals to 0. X-axis means what? Y equals to 0. So 0 equals to log 2c minus 3 to the base 3, because x becomes c. 2c minus 3 to the base 3 minus 4. So what does that becomes? Log 2c minus 3 to the base 3 equals to 4. What does that becomes now? 2c minus 3 equals to 3 power 4. 2c equals to 81 plus 3. So 2c equals to 84. So c equals to 42. That's going to be the answer. Now question number 11 is about graphs. Now he has given one simple graph over here, which is y equals to b power x, and this point has been given as 1 comma b, and this point has been given as 0 comma 1. Now in part A, being asked us to draw the graph for y equals to b power minus x, and in part B, draw the graph for y equals to b power 1 minus x. The parent graph has been given. So now, once we know b power x is an increasing function, b power minus x will be a decreasing function. So b power minus x is going to be a decreasing function with this is 1, and this point is still is it going to be 0 comma 1, because when you plug in 0 it's going to be getting 1. Whereas if at all I plug in negative 1, x as negative 1, then I'll be getting it at y to the power of y equals to b to the power of 1. So negative 1 comma b. This is going to be the equation. B to the power of x will be an increasing function. B to the power of minus x is going to be a decreasing function. Now b to the power of 1 minus x, it is also belongs to same b to the power of minus x family itself only. So it is also still a decreasing function. Now this point is going to be, if at all I'm plugging 0, so it becomes b to the power of 1 minus 0, which is b to the power of 1. So this point becomes 0 comma b. Whereas I need another point. So what am I going to do? If I'm going to plug in x equals to 1, if I'm going to plug in x equals to 1, so it becomes b to the power of 1 minus 1, b power 0, which is 1. So 1 comma 1. This is going to be the equation for y equals to b to the power of 1 minus x. Now question number 12 is again based upon radioactive substance. This time the equation is AT equals to A naught e power minus KT. And half-life. Half-life is already given as 1600 years. Next, he is asking us to find it out in part A, K. Find K in 3 significant figures. And part B, find percentage of original amount, left after 4000 years. So he's asking half-life. First of all, to calculate the half-life, we know that it becomes half of the initial value. So A naught upon 2 equals to A naught e power minus KT. So A naught gets cancels. So ln 1 upon 2 equals to ln e power minus KT. So ln 0.5 equals to minus KT. So T, then half-life is already given as 1600. So K equals to ln 0.5 divided by minus 1600, because we know that T value is 1600. The half-life is given as 1600. Simplify that, you should be able to get that answer as 4.33 to the power 10 times 10 to the power of negative 4, or 0.000433. This is the value of K. Now coming to part B. How much amount of is left over after, what is the percentage of it left over after 4000 years? So we know that half-life is 1600 years. We have to find what is the amount left after 4000 years. So A 4000 equals to A naught e power minus 0.00030 times 4000. What was A naught? We keep it as A naught itself only. Simplify this value with the calculator. It becomes 0.176930. So it is nothing but what? Approximately 17.7%. We can see that 17.7% of the A naught is left over. That's going to be the answer. Now coming to question number 13. Solve this equation. E power minus x plus 1 equals to 0. So what am I going to do that? I am going to draw the graph. E power minus x plus 1 equals to 0. It's going to be in this way. Then I'm going to find the roots for this one. So use the GDC. It's going to be giving you x equals to approximately 1.28. That's going to be the answer for question number 13. Question number 14. Solve for the values of x. Absolute value of 0.1 x square minus 2x plus 3 is less than log of x to the base 10. So for this also, I'm going to draw the graph for this one. So I'm using the GDC for this kind of questions. So draw this one. When you draw the left hand side curve, you'll be getting a V-shaped curve because it's an absolute value. Then log of x to the base 10 is going to be a curve in this way. Then he's asking us to find it out. What is he asking us to find it out? Where this absolute value is less than this one. So this green color region is going to be the answer. So for that, what am I going to do it out? I am going to find the point of intersections. Find the point of intersection over here and find the point of intersection over here. So it's going to be x lies between 1.52 to 1.79 in three significant figures. Question number 15. Then determine values of x. Determine values of x such that x e power x upon x square minus 1 is greater than or equals to 1. This is also the question based upon graphing calculator. So I'm going to use this graphing calculator and approximately get the shape. It may be in this way. I'm just approximately drawing the graph. This should be the shape of the graph, and x equals to 1 is a straight line. Now this is a 1. Then another graph is y equals to 1. This is the graph y equals to 1. So I'm drawing that graph y equals to 1. Now what is he asking? That graph is above the line. This is y equals to 1, and this is the graph of the left hand side. The blue color graph is this one. So now we can see that when I magnify and zoom and see, this green color region is going to be the region where what it says, the blue color graph, the left hand side is greater than or equals to 1. So and there is a part of a graph over here also. So we can see that x lies between -1 and -0.0800. So find the point of intersections. This point of intersection is -1, and this point of intersection is going to be -0.0800. And another value is nothing but what? X is greater than 1. X is greater than 1. This is going to be the answer. So this question number 15 is purely based upon graphing calculator. Use the graphing calculator and get the point of intersection. That will be giving you the answer. This is the end of the part 1. See you in the next video. Bye.